Let's talk about trig functions and their solutions. This section talks about solving trig equations. The idea of solving trig equations, remember, it always has to deal with where your curve is hitting a particular line. So, first of all, let's look at this example. What we want to do is we want to solve for theta. And you're going to solve this just like you would a normal algebraic equation, in that you need to get theta on one side. Or, for example, sine theta on one side. First of all, I have 3 sine theta on the left, minus 2, and 5 sine theta, minus 1 on the right. What I want to do is I want to move the 5 sine theta over, and I want to move the 2 over, so that now I have all my thetas on one side. Well, 3 sine theta minus 5 sine theta is a negative 2 sine theta equal 1. I want to get sine theta by itself, so I am going to divide by that negative 2. Now I want to solve for theta. Well, when I have sine theta equal value, the value, what you say to yourself is, okay, I need the angle for which the sine function is negative 1/2 in the region 0 to 2 pi. Well, that means I'm looking at the unit circle. So let's go to our unit circle. I'm looking for sine. Remember, sine is negative 1/2. Sine is y. So I'm looking for, where is the y, a negative 1/2? There's one. Keep going around because there might be more. And there's one. That means that sine theta is negative 1/2 at 7 pi over 6 and 11 pi over 6. So that means that theta is equal to 7 pi over 6 and theta is equal to 11 pi over 6. Very good. Alright, let's do another. Here again, I want to have the sine theta on one side and everything else on the other side. So what I need to do is I need to move the 3 sine theta over. Five sine theta minus 3 sine theta. I want to solve for sine theta, so I am going to divide by 2. So this again is the angle for which the sine function is negative square root of 3 over 2, again in the interval 0 to 2 pi. We're going to be looking at the unit circle. So again, I want to know where the angle, what angle is the sine function a negative square root of 3 over 2? Again, sine is y. So here's my unit circle. Looking at the y values, I want to look for a negative square root of 3 over 2. There's one. Keep on going because there might be more. There's another. Keep on going. Okay, so there's only 2 here. We've got 4 pi over 3, and we've got 5 pi over 3. So that means that theta is equal to, did I lose this? I'm sorry. It's positive square root of 3 over 2. That will do it. Okay, so let's try it again. Sorry about that. Looking for the positive y, square root of 3 over 2, square root of 3 over 2, there it is, pi over 3 and 2 pi over 3. It helps if I have the right sign, doesn't it? Pi over 3 and 2 pi over 3. So I have pi over 3 and 2 pi over 3. Okay, now that's if it involves one particular, well, actually here we've got two angle values that completes the, or solves the equation. Here let's talk about equations involving multiple angles. It says now we can concentrate on finding solutions of trig functions between one rotation. You can use a graphing utility to check your solutions of these equations. You graph the left-hand side, then the right-hand side. The solutions are the x-coordinates of the point where the graph intersects, and we'll solve the equations again for one rotation. The period of the function does play an important role in ensuring that we do not leave out any solutions. So let's get started by just going over a couple of examples. Here we want to solve the equation tangent of theta, or tangent of 3 theta is equal to 1 between 0 and 2 pi. Question 1 is what is the period of tangent? Well, the period of tangent is pi. Question 2, or let me say step 2, using only the interval between 0 and, let me say it this way, let me say it a better way, okay? Using the interval only 0 to period, let's do it this way, which in this case is 0 to pi, you're going to look for values for which tangent is 1. Now you might be asking, well, where did I get that 1 from? Why am I talking about it has to be the value of 1? Because here I'm equal to the value of 1 in my problem. Okay? Now, I'm going to look between 0 and pi, and I'm going to look for where y over x, because that's what tangent is, y over x has to be equal to 1. Let's go to our unit circle. Between 0 and pi, we're talking between 0 and pi half rotation, where is y divided by x equal to 1? Well, this won't get it to me. That one will. That's a pi over 4. Let's see if there's any more. That won't. Y divided by, nope, that's undefined. That won't. That's going to be a negative, right? That won't work, and that won't get it to me either. And that won't give it to me either. So here, the only y divided by x that's going to get you a 1 will be pi over 4. So this is at pi over 4. Okay, now step 3. Take the inside of the function. Take the inside of the function and set equal to the angle. Well, what's the inside of my function? The inside of my function here is 3 theta. So I'm going to take 3 theta. I'm going to set it equal to the angle. The angle I came up with was pi over 4. Now, use the period of the function. Again, tangent's period of tangent is pi. So that what we're going to do is we're going to say all solutions are given by 3 theta equals pi over 4 plus n times period, which in this case, 3 theta equals pi over 4 plus n pi, or pi n, okay? Because the period is pi. This is the equation that I will use to find all of my solutions. Step 4 then is to find all solutions by letting n equal 0 to, let's say, let n equals 0, comma 1, comma 2, comma dot 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 dot, until value exceeds, exceeds 2 pi. So let's talk about that. Okay. So now I have 3 pi equals pi over 4 plus pi times n. So first let n be 0. Okay, now, so I'm going to let n be 0. If n is 0, that means I have 3 theta equals pi over 4 plus pi times 0. Well, that goes away. That means I have, solving for theta, theta equals pi over 4 over 3, or simply pi over 12. Now, let n be 1, because this is still, this is less than 2 pi, that means continue. Okay? Okay, if n is 1, that means I have 3 theta plus pi over 4 plus pi times 1. Okay? That means I have 3 theta plus pi, equals pi over 4 plus pi. 3 theta equals 5 pi over 4. Theta equals 5 pi over 4 over 3, or 5 pi over 12. Now, this is again less than 2 pi, which means continue. Alright, so now let's let n be 2. It means I have 3 theta equals pi over 4 plus 2 pi. 3 theta equals 9 pi over 4. Theta equals 9 pi over 4 over 3, or 9 pi over 12, or 3 pi over 4. This again is less than 2 pi, so continue. Alright, let's let n be 3. 3 theta equals pi over 4 plus 3 pi. 3 theta equals 13 pi over 4. Theta equals 13 pi over 12, which again is less than 2 pi, so continue. Generally, they're not this long, but I want to get you in the hang of continually plugging in the ends, okay? Alright, well, continue. N equals 4. 3 theta equals pi over 4 plus 4 pi. Alright. That means I've got 3 theta equals 9 pi. No, I'm sorry. 17. 17 pi over 4. Let me fix that so it looks correct here. 17 pi over 4, divide that by 3, 17 pi over 12. Again, it's less than 2 pi, so continue. How do I know I'm less than 2 pi? How do I know I'm less than 2 pi? 12 goes into 17 how many times? 1 full time, which is obviously less than the number 2, so I continue. Okay, let's let n be 5. If n equals 5, 3 theta equals pi over 4 plus 5 pi. 3 theta equals 21 pi over 4. Theta equals 21 pi over 12. Simplify. 7 pi over 4. 4 goes into 7 one whole time, which is less than 2, so I'm going to continue. Almost done. Let's look at n equals 6, and this is how we're going to know we're done, okay? 3 theta equals pi over 4 plus 6 pi. 3 theta equals, let's see, 24, 25, 25. pi over 4, solve by moving the 3 over by dividing. 25 pi over 12. This is how we know we have finished. Now, 12 goes into 25 2 full times with 1 left over. This is larger than 2 pi. This means stop. This is not in the interval 0 to 2 pi, so do not include. Therefore, my solutions so the solutions are theta equals, alright, when n was 0, I got pi over 12, that's one solution. N was 1, I got 5 pi over 12, that was one solution. 9 pi over 12, that's another solution, or 3 pi over 4, I should say, is another solution. 13 pi over 12 is a solution. 17 pi over 12 is a solution. And 7 pi over 4 is a solution. Again, this one is not because it's not in the interval. So our solutions are pi over 12, 5 pi over 12, 3 pi over 4, 13 pi over 12, 17 pi over 12, and 7 pi over 4. Now you might be wondering, okay, good gosh, that was a really long problem. They're not that long all the time. One way that you know that you have to do this as opposed to, because the question might come up of, okay, well, how do I know when I'm supposed to do this as opposed to just stating, the angle between, okay. You ask yourself, you write this statement, the angle for which, the trig function is the angle, or is, equal to the angle. Okay, you write this statement when you have something like this. Sine theta equals a half. You have to do the 4-step process that we just went through. When you have more than theta on inside of function. For example, tangent of 3 theta equal 1. Notice the difference here. The difference here is that this has theta and just theta, which means I can just state this, look at this, and look at the unit circle. Look at this one though. This one has 3 theta, which is obviously, there's more than just theta on the inside, so I have 3 theta. What do I have to do? That 4-step process. Okay, let's look at another example so you can see then which one you're going to use. Okay, here's one. Well, let's look on the inside. Sine of theta over 2. Alright, is theta over 2 more than just theta? Absolutely. So am I going to make this statement, or am I going to do the 4-step process? Well, because I have more on the inside, right? Because I have theta over 2, which is more than just theta, I'm going to have to do the 4-step process. So, 4-step process for this one. Alright, step 1. What is the period? The period of the sine function is 2 pi. Step 2. Using only the interval, 0 to 2 pi, look to see where sine is square root of 3 over 2. Again, you might be asking, well, where did I get that square root of 3 over 2 number? The problem says that I'm equal to square root of 3 over 2. Alright, that means that I'm going to look in my unit circle for where the y is square root of 3 over 2. Y is the square root of 3 over 2 at pi over 3 and at 2 pi over 3. That means I have pi over 3 and 2 pi over 3. That means I have two angles for which this solves, which means that for step 3 I'm going to have two equations. Okay, remember step 3 was to take the inside of function, at pi over 2 in this case, set equal to angle. So I have the inside, theta over 2, set equal to pi over 3, and I have the inside set equal to 2 pi over 3. Step 4 was to find all solutions. All solutions are of the form, take your equation that you have and add n times period. So take the equation that I have and add n times period. That means I have theta over 2 pi over 3 plus 2 pi n, theta over 2, 2 pi over 3 plus 2 pi n. That means that now I let n be 0, and then 1, and then so on and so forth. Alright, so let's solve this by finding our solutions. Let n be 0. If n is 0, I have theta over 2 equals pi over 3 plus 2 pi times 0. Theta over 2 equals pi over 3. Multiply by 2 to finish this out, so you get 2 pi over 3. On this side, theta over 2 equals 2 pi over 3 plus 2 pi times 0. Multiply by 2 to solve this one, 4 pi over 3. Both of these are less than 2 pi, so continue. Alright, let's let n be 1. If n is 1, I have theta over 2 equals pi over 3 plus 2 pi times 1. Theta over 2 equals 2 pi over 3 plus 2 pi times 1. Well, I've got theta over 2 equals 7 pi over 3. Theta equals 14 pi over 3. 3 goes into 14 how many full times? 4 full times and 2 left over. Is this bigger than 2 pi? Absolutely. So stop and don't include. Let's look for this side. I've got theta over 2 is equal to 8 pi over 3. Theta is equal to 16 pi over 3. How many times does 3 go into 16? Well, that goes in 5 times with 1 left over. Is this bigger than 2 pi? Absolutely. So stop and don't include. Okay, that means that my only solutions to this are 2 pi over 3 and 4 pi over 3. And that's it. Most of them are this short. Most of them are not as long as the first one.